What's up guys, this is Youngno. Let's solve this question. In this question, we have a quadratic equation that has two distinct real solutions. And what we're looking for here is one solution of those two. To solve the given quadratic equation, I think you have to try with factoring technique first, and if it doesn't work, then you have to use quadratic formula. But since we have a bunch of unknown constants here instead of actual numbers, using quadratic formula might make everything very complicated. So why don't we give it a try with the factoring technique first? Quadratic coefficient AB can be factored out into A times B, and negative 216 here, it can be factored out into many different ways. We have a problem here. It has so many options, 2 times 108 with one of them with negative, and maybe 3 times 72, one with negative, and so on. Since 216 can be factored out into many different ways, it's really hard to factor this given quadratic equation out. But the thing is, we have a hint here. A is supposed to be multiplied by 12. And B is supposed to be multiplied by negative 18. And negative 18 times 12 happens to be negative 216. So we're almost done. First factor should be A times x minus 18, the first row. And here comes the second factor, bx plus 12 equals 0. So by setting the first factor equal to 0, you can find the solution. It's 18 over A. And by setting the second factor equal to 0, you can find another solution. That is negative 12 over B. Since we have negative 12 over B here, answer choice A has to be the correct one. For those of you who are not familiar with this factoring technique, there's another way. We can set the values of unknown constant with some fixed values. When you're trying this, setting the values of unknown constant equal to some constant, then you have to set them equal to prime numbers. Because if you set them equal to some really basic number like 1 and b equals 1, then you might end up with more than one answer choices that make sense. So let's start with assigning prime number values onto those unknown constants. If a equals 2 and b equals 3, then quadratic coefficient is 6 and linear coefficient is 24 minus 54, that is negative 30. So this is the quadratic equation if a equals 2 and b equals 3. And finding solution to this quadratic equation is very easy because we have decimals. So I'm just going to draw the graph of that quadratic equation. 6x squared minus 30x minus 2, 1, 6. We're looking for x-intercepts. We have negative 4 and 9. So if a equals 2 and b equals 3, that quadratic equation is supposed to have these two solutions. Answer choice A. Since b is 3, this is negative 4. Answer choice B. Since b is 3, this is 6. Since a is 2, this is 6. And since a is 2, this is negative 9. We have only one option. What did I tell you? If you start with setting a equals 1, b equals 1, a very simple basic case, then you might end up with more than one answer choices that make sense. So when you're doing this kind of approach, assigning fixed concrete value to unknown constants, then you have to assign them prime number values. That could work most of the cases. So when you're stuck, try this one. We're done. See you on the next question.